I'm using magnets for many of my 3D printed projects. Here I used magnets so the parts are snapping to specific positions. In my camera puzzle box I used magnets for the trigger mechanism. But working with magnets can be a challenge. Often they don't stay where they are supposed to stay. You may get super glue on your fingers, or you find out you glued them together in the wrong orientation. So I tried to fix this. With a first concept of the mechanics in my mind, I started Blender. I started with this as my core part and built everything else around it. The case and the handle to initiate the motion. This is how the first prototype looked like. I didn't care much about its appearance as the functionality was my focus. The first redesign was to give it a basic shape, making sure it fits my hand and can be operated by my thumb. The second redesign looks similar to the previous one, but it's slightly optimized. With the third redesign I put more focus on the appearance. I wanted it to look slightly futuristic, but there is still room for improvements. The final result looks like this. Okay, but how does it work? The plan is to attach two magnets to those two ends but differently oriented. By pushing the handle in, the other magnet will take the bottom place. The magnet I want to insert sits on the bottom. The tool is then placed on the target spot, and by pushing the handle in it will switch out the magnets. Now I can remove the tool, pull out the handle and pick up the next magnet. That's the theory. Before testing it in reality I have to print the part. I printed them on a Anycubic Cobra 2 Pro using Elegoo's Rapid PLA. The device is assembled quickly. There are not many parts and many of them are just decoration. But it's important that the moving parts can move without any resistance. Don't screw the bolts too tight, otherwise it may block the mechanism. Following the assembly, it's finally time to test if it works. This is always the most thrilling step. I spent countless hours on something that works in my mind, but I have no idea if it works in reality. I picked up a magnet, placed it on the hole, pushed in the handle, and it worked. But not as good as I expected. Sometimes the magnet flipped when lifting. After some more testing I noticed it only happens when I'm not lifting the device perfectly upright. I'm not really happy with that, so I tried to remove one magnet by simplifying this part. I switched them out and gave it another try. It seems to work better for now. Time for a stress test. I ordered more magnets, printed a matrix of 64 holes and started testing. I didn't use any glue for this test, which makes it even harder. But as you can see, it works perfectly. Doing this the old way and making sure all magnets are inserted the correct way would be a challenge. I did not use any glue because I didn't want to waste 64 magnets on this test. The But of course I need another device for the other pole of the magnets, so I printed another one in blue. This is just a little demonstration to show that you can easily handle the tools with one hand and keep full control over them. I already used it on one of my side projects that require a lot of magnets, and it really improved my workflow. Not a single magnet is facing the wrong way, no super glue got stuck to my fingers, and I saved a lot of time. But of course, this tool is not perfect. It's limited by its size. Some spots may be out of reach. I only tested it using 5x1 mm neodymium magnets. Other magnets may behave different. And reloading the tool still has to be done one by one, which probably takes most of the time when using it. But that's something I might have a solution for and will be a topic for another video. The advantages outweigh the disadvantages, and I will use it for all my future projects that require magnets. I uploaded the STL files so you can download them for free and print your own magnet inserter tool. Thanks for watching and see you next time.